as we go, but this is being recorded, so you'll be able to watch it later on YouTube if you've missed the beginning. So we're excited to present today's training webinar all about OpenSees. And before I hand it over to Sylvia, I just want to mention a few things. First, we have this QR code where we have a survey, and we always utilize survey results to improve our webinar deliveries. And we would very much appreciate you taking just a minute or two at the end or after the webinar to provide us with some feedback that we can use to make these things better and best address the needs of the DesignSafe community. So with that, I'll briefly introduce Sylvia and leave all of the time pretty much for her to talk to you about OpenSees and some new updates to the documentation. All right, good to see you, Sylvia. Your camera's working. So Sylvia's been part of the OpenSees development team pretty much since the beginning, right? 23 years or so of OpenSees. If you've run OpenSees using some of the documentation, you probably have Sylvia's code in your scripts, right? Maybe without knowing it. She has really been a strong interface between OpenSees and the user community, provided a lot of help. Recently, she's been working on updating documentation, kind of giving advice on when to run things on the HPC resources, when to do it locally, and so forth. And she also started Sylvia's Brainery, so go check that out. It's a great channel. You can get OpenSees instruction there as well. So today, well, now she's working on with DesignSafe to optimize the integration of OpenSees with DesignSafe and update that documentation, which I think is part of what she'll present today. This was the description of the of today's lesson, and I won't read all of this because all of you probably saw it when you signed up for the event. So with that, Sylvia, thanks so much for being here. I'm really looking forward to it, and I will stop my share and hand it off to you.
Thank you. Can you hear me?
Yeah, sound good.
Okay, perfect. I guess I should have read that description before I did prepare the presentation. So I'm guessing I'll stick to the code. You see my screen?
Yeah.
Okay, perfect. Good morning, everyone, afternoon and night, wherever you are. What I like is it'd be nice if everybody just for a second could just turn on your cameras to kind of say hi to everyone. It helps me to feel like I'm not talking to a few talking. I'm not the only talking head here. But again, I can't see the gallery, so I'm hoping to be able to see everyone. But just if you can turn on your camera and just wave hello to everyone, it'd be nice because we're a big community and I see a lot of familiar faces, a lot of new faces. So great to have everyone here. All right, ready to get started. So today's workshop is going to be about running OpenSees on DesignSafe with the focus of the concept of scalability as by design and part of your design of your OpenSees projects. I just learned how to do animations on or transitions on PowerPoint. So you'll see a bunch of those, but I'm trying to use them to guide you where I want to take you in this presentation. So don't let the fancy graphics distract you, but just come with me on this little journey that we're going to take with OpenSees. There's an assumption that you're familiar with what OpenSees is and what it does. There's lots of documentations online. So my focus today is very much running it on DesignSafe and why and how you do so. Okay, so let's get started. So why run OpenSees on DesignSafe? That's the very first question that I've asked myself many times because I ran a project a while ago, all my analyses, I had to do millions of analyses and I did them on DesignSafe. But my daily OpenSees work is always done on my desktop. And so in the last few months, as I've been getting to know DesignSafe in and out and working with them, I am really finding a lot of answers and positive answers to why we would run OpenSees on the DesignSafe. And the key word is indeed scalability. You can really scale your model and your project and what you're trying to do with your data all within DesignSafe. And so I really want you to keep that in mind as you think about where you're getting started with OpenSees and where you go on your journey. So what is scalability? Well, we start off with, OpenSees example 1 that I wrote over 20 years ago. That's in the wiki, and then you scale up, and scalability means being able to run lots and millions of different variations of different structures and different ground motions or different load cases. And so how do we get from example 1 all the way to this large data set? And so let's take it one step at a time. So when I wrote the example 1, I wrote it on a laptop that is probably not as powerful as the cell phone that you're holding in your hand right now. But that works because it's a simple example. There's no input file, or there's one input file that doesn't read anything else, and everything is elastic and simple. And the examples manual goes all the way to example 8, which now you've scaled up a model size, a much larger structure. We've gone to 3D, not just a 2D model, maybe some nonlinearities in your elements, as well as now we're running a ground motion. And you know what happens when you run one ground motion, you got to run many. Okay, so I went through, and if you go through the examples files, each one at different levels, I'm really working with you in scaling up your knowledge and understanding of OpenSees. So I always recommend that that's a good place to start. But that's on, OpenSees itself. Now we're talking about how do we run these? Well, now what you want to do is you want to do a little bit of work and maybe run this larger model with this ground motion, maybe on your desktop. Your laptop can only handle so much, right? And so that's scaling up already. So just as your demands scale up with your model size, now your computer needs to scale up proportionately as well, or if not more than proportionately. And now what if we start bringing in not just a model size, but we start bringing in parameterization, right? Now we've got many more analyses that we need to run, maybe on a single model. So now we may need to, go maybe 2 computers, 2 desktops, which is something doable. You can always see it as 2 cores, or you can do parameterization on your model. So maybe you have one ground motion and many different variables in your structure, maybe the number of stories, different material properties. And then the next level is, a few models and a few ground motions. So now things really scale up again, that it's a 2x2 matrix, right? Or an n-by-n matrix. So your model and your requirements scale up with all these different parameterizations that you're running. And so now things get really interesting if you need to run an infinite number and in an optimization problem, or if you're doing some sort of IDAs or different, just lots of different parameters, or maybe you're looking at a regional study. And so now you really need to start talking about compute resources. You're no longer just talking about your desktop. Maybe you might need to go to a cluster. And this is the flow that we have done as we scale up. Now, of course, we were talking about just the model itself, but the other thing you need to take into account is data. All right, so when you've got even just my cantilever column that's elastic still has one file for all the nodal reactions, one file for nodal displacement, and another file for maybe some section forces and deformations. So even just one simple structure has a single file. And so now if we go to a large system, now you're talking about folders and folders of a lot of data. So even the data now you have additional requirements as you scale up your model. And of course, you might need to go to a database to manage your data set. So things really scale up as our compute resources grow, even just on our desktop. We can even do this all on our desktop. The problem with doing it on the desktop is at some point you run out of something, either memory, time. You can't check your email while you're running all these. And even my biggest problem is disk space. I just keep on running out of disk space. And so I have to go to external drives, which are really slow. And so now I'm kind of hitting a wall when you're trying to optimize all this different work. It's doable, but it's difficult. So what do? Most people just go into DesignSafe at this very, very last stage. And that's great, but this can be, you're not really leveraging all that DesignSafe can do for you. It's difficult to transition from your desktop to the compute resources on DesignSafe. So optimally, what you really want to do is to bring everything, from your very beginning of example 1 all the way to your large parametric study, to do this seamlessly and scalably within DesignSafe. And so that's what the focus of today is I want you to build this picture and have this picture in mind as you think about where you're starting with your OpenSees model, very much targeted from the very beginning as to think about what your plans is, where you're starting. You should always start with something simple that works, and then add to it slowly and scale up. And so if you can do this directly in DesignSafe, it all becomes seamless because you've got one location for your data and all these different resources that you can walk through. And that's what I'm going to walk you through today. And so the key concepts that I will address and talk about and things that you need to keep in mind is your model size, and I'll explain what kind of things control your model size. Parameterization, that takes up memory, processors, and also a lot of data and time. Your compute resources, as well as your data and your data storage and access. So these are the 4 different keys that for me really drive, and something that you need to keep in mind at every stage in deciding what to do with your OpenSees model, what to run it on, and how to run it. And so these 4 different concepts, we can almost group them between your application and your resources, right? So the model size and the parameterization, that's something that you're running. So which OpenSees is really the optimal version of OpenSees that I can use, or optimal application, as well as your resources is, on the other hand, what computer resources do I need at each stage of my model. And so that brings in the concept of planning and designing your workflow. So how do you start from the very simple example and build your way up to your billions of analyses? And it's great with DesignSafe because you can do all that, quote unquote, in-house. And so as you do that, it's pretty much 3 simple steps. First step is to select your OpenSees application, and that's decided by your model size and your parameterization. And it's almost like these 2 things together, it's the size of your project. And I'll identify again what those different items are. So once you've selected your OpenSees application, you need to decide where to run it and how to run it. Where do you manage it? Do you do it on your desktop, or how you do it on DesignSafe? And then it's simple, you just click button and run. If you do things properly and you follow the steps of the different resources that you have available in DesignSafe, it's going to make your run time a lot faster. You may not need to iterate as much on trying to debug, and I will show you what are the resources that are really helpful in debugging your model. And so these are literally the 3 steps, very simple to run OpenSees, of course. So, of course, this becomes an iterative process because you want to do this starting from a small scale of your project. And as you build up your project, you may need to switch. Maybe you can start with the serial or sequential OpenSees, and then trying to decide which parallel application for OpenSees to use. And I will show you today what these different applications are and what the recommended use is, or intended use almost. And so you will loop through this as your project grows. And also, it's not just a simple project. As you grow and the different projects that you work on with OpenSees, if you have this in mind, it's very easy to not start from scratch every time. And so I think it's really important to get a good understanding of what you're going through here. Okay, so let's look at the very first part of it, which is selecting your OpenSees application. So 2 things I want you to keep in mind, and these I almost define, I think, in the documentation. I call them the scope of your project, because one is the model size, which is what we always talk about, but also keep in mind, how you're doing your parameter studies. So the model size affects the size of the system of equations, right? Your matrix get bigger and bigger as you increase these different parameters that I'll talk about, which means that not only do you need more memory to invert this stiffness matrix, but you may have more elements that go nonlinear or inelastic, and so you need to do these state determinations that can sometimes be iterative. So the different points that affect your model size, and this is important because you want to minimize your model size. It's not just, oh yeah, well, I'll just do this in the supercomputer. No, you can really optimize the number of dimensions, for example. So are you in 1D? Are you just doing some simple springs or not, zero length elements, all the way to 3D structures, right? The number of degrees of freedom per node. You can have springs that are just 1 degree of freedom per node. Quad elements have only translational degrees of freedom, and beam column elements have 6 translational degrees of freedom in 3D. And so the types of elements, as well as the number of nodes and the number of elements, really affects the size of your model. And so if you've got, for example, the regions where your structure is going to remain elastic, you can really reduce the size of your model by just using elastic elements or elastic sections, for example. Also, how you discretize your element is important. What type of element are you using? Are you using the force beam column element, which really only requires 1 element per structural component, or are you using displacement beam column elements that require much finer discretization? At that point, also the number of integration points for the force beam column element, right? So you want to optimize all these, and those really affect the size of your model. And then, sections, if you're using fiber sections, for example, they require more memory and processing time. So fiber sections in OpenSees are really there for PM interaction and PMM interaction, right? So it really should only be used in columns that have enough variation in axial load or enough biaxial bending to affect the response. So you shouldn't really be using fiber sections at all your elements and across your entire structure. And if you just optimize that, you may not even need to go to any sort of larger capacity OpenSees application. So this is something I really wanted to get across, is optimize your model size and reduce it as much as possible, okay? Because that will allow you to grow your project, to run that many more time series, that many more variability in your parameterization. And of course, materials, there's some materials that are just memory intensive. So be very careful in the selection of materials that you use. I always recommend to use materials that are well tested, and that don't have a million different variables that they're keeping in mind. So if you're using a special material, make sure you look at it and you evaluate it and think about what its requirements are. So that's on the model size. Then the parameterization is, again, it takes up memory and processors, and it creates more data and time. And it's how many configurations and variations you have in your model or in the loading, right? You can be studying the effect of material strength or the number of stories or the story height, or you can have different variations of ground motion scaling. Maybe if you're doing wind loading, different wind directions, right? And then the other important thing to keep in mind is what type of parametric analysis are you doing? Are your analyses independent of each other, or are they interdependent? Because if you have an analysis like an optimization solution, then the results of one analysis are dependent on the results of another. And so now you may need to run some analyses in sequence while you can run some other analyses in parallel. We're used to just running a bunch of ground motions, and so those can just be run in parallel, but there's other applications where some parts can be run in parallel and some parts can be run in sequence. And so these are things that I want you to think about before you even open up OpenSees. And this is pretty much independent of whether you use OpenSees or any sort of finite element program, right? Or any sort of project that you have, okay? So now that you've thought about, okay, I have an idea of what my model size is and what my parametric study is going to be. Now let's talk about what OpenSees application you have. Okay, we're all talking about just OpenSees in general, but now there's like certain types of OpenSees that Frank McKenna developed when, it was even just from the very beginning. OpenSees was conceptualized, designed, and developed from the very, very, very beginning with parallel computing as its core. That was really his, Frank's thesis was about parallel computing. And an application design, and I think I stole this quote from him, or I may have rephrased it. An application designed for parallel computing takes advantage of multiple processors working simultaneously on independent as well as interdependent tasks. Okay, and while they can pass information to each other. So for example, I use OpenSeesPy a lot, and I use concurrent futures. Well, that's a great way of parallelizing, but now I'm using a separate library. If you can bring the parallelization directly within OpenSees, now you're using your resources much more efficiently. And so if you can do things within OpenSees, it's the best thing, okay? And so there's 3 different and very different personalities of OpenSees applications. You see them here on the left-hand side. We've got what we all call OpenSees. Just to identify it here, it's called OpenSees Express in DesignSafe, but it's the OpenSees.exe. And it's a sequential application. Then we've got the 2 parallel applications. We got OpenSeesSP and OpenSeesMP. They're very different applications, and they're targeted to different types of parallelization, and I'll talk about those 2. These are typically considered in the TCL interpreter that you're all familiar with, but I think you're familiar with the OpenSeesPy, which is a Python interpreter. OpenSeesPy, I'm putting it in here. I'm not going to talk about it so much because it's more of an interpreter issue than a core, whether you're using OpenSees, sequential, or parallel. OpenSeesPy actually takes all the features of the 3 different OpenSees and integrates them into one. I'm not going to talk about OpenSeesPy too much, but I wanted to put it here just so that it's clear and for completeness. I'm a big fan of both the TCL and the OpenSeesPy versions. They're kind of, it depends on what you're trying to do. Right now, I'm working with DesignSafe to bring as much capabilities with OpenSeesPy, even in the web submit for functions, but we're not there yet. Okay, so but remember, OpenSeesPy is there. Most of the time now I'm going to talk about just OpenSeesMP and SP and OpenSees Express as individual applications independent of what the interpreter is, whether it's Python or TCL. And so if we break these up, the OpenSees Express is the simplest application. It's just what we're used to. We download it, we run it, and it just runs on a single core, very easy to use. And it's really the best place to start, or it's the place you should always start. And oftentimes it can easily meet most of your project needs. Most of us are just doing nothing grand yet, nothing to volume yet. We're trying to maybe do some development. And so a lot of times just the regular OpenSees Express can meet your needs, especially if you optimize the design of your model. The parallel applications, OpenSeesSP is the single parallel interpreter application. This is a single processor that distributes the large model to the different processors, okay? So this is called the model decomposition. It does automatically internally, and it's very easy to use, okay? But it's one processor that distributes the model. So this is great for large models. OpenSeesMP, on the other hand, is the multiple parallel interpreters application. I put these in quotes. Google this. There's a resource that I put in the documentation that's really interesting about this. This is a concept beyond OpenSees. This is the most versatile application. It runs in all the processors in parallels. You assign the tasks to these processors, and you can do both the decomposition as well as the distributed parametric analyses, which is what most people use it for. It's excellent. It's a lot of fun to use, and you can even improve it by looking at some load balancing techniques that you can really optimize the number and the way you run the analyses. And as I've mentioned, OpenSeesPy is OpenSees in the Python interpreter. It has SP and MP features, in it, and I'm working with Minji to make sure that that version of it is in DesignSafe. I want to just really keep on digging a little deeper into each one of these. This is the OpenSees Express is your starting point. There's now, the question is, how is it different from what I could do at home? It's actually, it's the same program that you can run at home. And therefore it's ideal for small models and small load cases or few load cases. In DesignSafe, it runs in its own shared virtual machine. And so the advantages over your little computer is that you have access to all the files that are available in DesignSafe. And your output goes directly in DesignSafe. So you can bring in data sets that are from other projects, as well as, contribute to different projects. And oftentimes the DesignSafe hardware just has better computer resources, especially the read-write speed, and of course the disk space. The disadvantage is just only runs sequential analyses, and the virtual machine is a shared resource. In DesignSafe, there's two ways that you can run this sequential version. One is through the interactive interface that I'll show you. It's really cool. It's a new thing that we've just brought in the last couple of months, or just submitting it through the web portal with a simple click of a button. OpenSeesSP, as I've described already, is intended for large models with very few load cases, because you're really running the analyses in sequential order. The application is actually going to read the script just as it does with your sequential application. But internally, if you're using this and you use the specific solvers that go with it, and of course you need to look at the documentation examples, what it's going to do, it's going to distribute the solution and the equations to the different processors. So it does a domain decomposition and assigns each domain to the different processors, and then they do the state determination locally, and it recombines, and it does all this seamlessly. You don't really have to do anything other than specify parallel solvers. It runs on the HPC, which is great because it's difficult to get it to work on your own desktop. Same thing with MP. And so it's easy, and you have very easy access to it on DesignSafe. Everything is done automatically, and the distribution or the parallelization process really speeds up your analyses. And this application is the easiest of the parallel applications because it does everything automatically, and the partitioning, and you don't really need to do any additional scripting. You don't have any control over it, of course, which means it's one of the disadvantages is that the order of the data, if you have recorder files that are asking for many different nodes, they're not always in the same order, but if you look at the documentation, it tells you what to do to figure out what is in each file. And all you have to do is use the XML flag. So it's not that complicated. Of course, it runs on the HPC, which means it has a queue. It depends on if you submit it to the web portal, you have one type of queue. If you work directly in the HPC system, you have a different type of queue. In DesignSafe, there's a lot of examples in the community data. There's a lot of documentation on OpenSeesSP, so you're set to run it in DesignSafe. If we switch over to OpenSeesMP, which is the multiple parallel interpreters, now you get a lot of fun, let's call it that. It's the most versatile because it allows you, but therefore requires full control by the user. Each processor interprets the same script. It's all done in one script. You're not really sending different scripts, but within the script, you say, hey, if your processor 1, do this. If your processor 2, do this, and and so on. So you put into the script which processor does which work, whether it's from assigning which nodes and elements go to that processor, or which analyses are being run by that processor. And so that's the big difference between MP and the SP. SP is just simple. That's what the S stands for me. It's a simple parallelization, while OpenSeesMP is the most powerful OpenSees of all of them. It's really not that bad to use because there's very simple concepts that you can just see in the examples of how to manage the different types of analyses. The advantages is just it's super fast and versatile and powerful. It may require a little bit of extra work at your end, but once you've put in this extra work and understanding, you can really just run a lot of analyses. Now for parametric analyses, it's simple. You just distribute the analysis to them. What's good about it is that the parallelization is handled directly by OpenSees. And so it is faster than doing it manually. I mean, I can write a batch file that assigns different jobs to different tasks. And in addition, you can actually improve the speed and the efficiency of your solution using load balancing solutions. Frank has a great video on load balancing solutions, and I put a link to it in the manual in the documentation on DesignSafe. And again, there's just a few extra commands that you need to learn, and so that kind of becomes a disadvantage. You need to learn a few commands, but it's not the end of the world. It runs on the HPC, so that makes it faster, but it also means there's a queue that you have to wait for it. The disadvantage is really its advantage is that everything is fully manual in the parallelization. And so you need to do some additional scripts for managing your analyses, which is why I was a big proponent to introduce the interactive OpenSees machine that I'll talk about afterwards, where you can test your OpenSees model, especially the OpenSeesMP, make sure that you're doing things the way you want to in a small scale, and then you can go to larger scale by submitting to the web portal, and then even larger by going to HPC. In DesignSafe, it's very well documented, lots of examples, and a lot of examples beyond DesignSafe. So a lot of people are using both OpenSeesMP and SP, and the additional concepts that you need to learn are not that complicated. And so it really becomes a big improvement to your model building. Now, of course, I needed to put all those words into something that I could look at quickly, because I'm a big believer that your brain processing faster than your mind. And so I put together a table that's just meant to be as a guide. So on the left-hand side, you have your job configuration, right? We're talking about model size, as well as the type of analyses you're running. And then on the right-hand side, just different comments and recommendations as to how each one of these applications should be used. So for example, if you've got a small to medium model with very few analysis parameters, stick with the sequential OpenSees. It's faster, it's easier to access, there's no queues, and it just works better for you. But if you're running a lot of analyses, then maybe you should go to MP. Doesn't mean you can't do it in the other applications, but it's not an efficient use of your OpenSees resources. Same thing with a larger model. Of course, this is all relative. And then for a large model, it depends on if you have very few analyses cases, definitely go with SP. It's just so much easier to use, and it does everything for you. And if you don't need to run sequentially, and you can just run a few instances of it anyways, it may actually be, it is the recommended way to go. With OpenSeesMP, you can do both cases, and remember, just with additional scripting. And so I put a few notes as to why you would recommend something, and this is you'll find in the documentation as well. Everything that I'm showing really comes from the additional documentation that I've been working on in the last couple of months. So this table is just a really nice, quick visual to understand based on the discussions that I've gone through already in the different descriptions. Okay, so now we've done step one. You've understood what the different OpenSees applications are. They have different applications for them, and you got to make sure that you understand all of them and you choose which one you will use at the different levels. And again, you're going to want to evolve through these. Then the next step would be to select your resources on DesignSafe. One is to think about data storage, and so I want to bring that up as the different points to think about. And then looking at your resources, what are your different options for running OpenSees on DesignSafe itself? So if we look at the data depot is a huge resource. It provides you access to a lot of published and shared data. It's integrated in your path. You don't have to go and grab things. You can just link directly to that. The published data has model information. A lot of people have shared models, so it could be a good place to start, as well as lots of data sets, right? There's databases of ground motions, as well as a lot of simulated ground motions. And so you don't have to download all this data, download and upload it. And when you're done, it's very easy to publish your large data set. My data is your local folder in your DesignSafe account. It's definitely got a lot more storage than my desktop. I don't know if there's limits or not, but I like it because I found data that on projects that I worked on, years ago. And so it really brings in a lot of continuity. You can bring in others to work on the data and share the data. So it's a very efficient location because you're not just storing the data, but it's very easy to access the data to it directly. The other point I want to talk about on data is the storage on the nodes. Nodes are computers, okay? On the supercomputer has nodes, and they're like little individual computers, and each node has its own processors, right? And so if I give you a node, it's as if you have your own little virtual machine. But of course, all these nodes are connected as well, and there's billions of nodes. But what's important is the slowest part of any analysis is the I/O, and you've heard me say this before. Writing and reading files takes a long time, especially the writing to the files, not especially the recorders, because there's an optimization way of how they're written, but it still takes time. So you want to minimize the travel distance. And so when you submit jobs through the web portal that are sent to the HPC system, you'll see that the HP system actually clones your data to the hard drive or the disk space or the scratch directory of that node. And that makes it super fast, a lot faster than having to write to your C drive or your D drive or your external drives. And so that's something really powerful when you're working in the HPC system. It's not just processors and memory and speed. A big one for me is the space and the access to the data. So this is definitely a plus in working in the supercomputer world when you've got you're generating a lot of data, which you definitely do with OpenSees. And so that's something that I want you to keep in mind as a resource that you have on DesignSafe. Then the other resource, of course, is the compute resources. Now we're talking about processors and memory and nodes. And there's 4 different options that you have for running OpenSees on the DesignSafe CyberInfrastructure. Excuse me. I put a number to them because they are in sequential order, that you start with 1 and you work your way up and up, depending on your needs. So 1 is this new thing, the interactive virtual machine that I'll tell you about. It's really cool. It's got a user-friendly environment because it's a Jupyter Hub type of environment, but it's preset and it's already preloaded with OpenSees, OpenSeesMP, SP, as well as OpenSeesPy. And you can run them interactively. Of course, you can't really run OpenSeesMP interactively at, writing in each line of input, but you can run it, call OpenSeesMP, run it, gives you an error, fix your script, and I will show you the workflow there. The interactive machine requires, that you're actually in there. If you're working in the Jupyter world and you're used to working with having to script, but even with the OpenSees and the Tickle input, you open up this very simple terminal, and I'll show you how easy it is to work through there, but you still need to specify things. And so it's a great place to start in debugging your model. and building your loops and everything and testing your script. Then it's a lot faster to submit your script to the DesignSafe via the web portal. It's really cool feature because they do all the back-end work for you. You just tell it, what your input is and how many nodes you want to use. And this gets submitted to just 2 nodes on Frontera. Frontera is the big machine, and they reserved some space to, sets of 2 nodes for jobs that are submitted through DesignSafe. So you're really accessing the HPC system without having to do too much scripting and having to request additional, allocation. But, so this is good for a relatively moderate size scope of your project. Again, that probably meets the requirements of most of us. And it's really nice and fast way of submitting. There is a little bit of a queue, but it's in the fast queue or the small queue anyways. The other option is to go through Jupyter Hub. Jupyter Hub integrates OpenSees into your workflow, not just, we're used to thinking, okay, Jupyter and a Jupyter notebook for OpenSeesPy, but the other way you can use the Jupyter Hub is you can use your notebooks or just Python in general. There's even just the Python terminal that you build your pre and post processing. And then from the Jupyter Hub, you can actually submit jobs to the HPC. You need to specify, some information about your allocation. But it's a very powerful step at the next step if the web portal is just not enough for you, because for the web portal, you have to prepare your scripts. And so integrating the Jupyter Hub, now you can integrate writing your scripts and doing the post-processing all in one workflow. So I think it's an awesome resource for whether you're using the Tickle version as well as the Python interpreter one. And depending on where you want to submit it. Then TACC is the next level up. That's where I ran my billions of analyses, and just require, if you just really need really, really powerful resources. And there you work directly in the Linux environment, but it's not like you just say OpenSees. You can do, OpenSees, but you can also, there's a lot of resources to speed up and run parallel jobs. I'm not going to talk about those today, but it's a very powerful feature for scaling up big time your OpenSees analyses. And so as you can see here, there's a workflow as you step up, as you build your model, as you start from example 1 in the iterative virtual machine, but then you can even test your example 8 and your large parametric studies in the virtual machine to then see where you want to send it if you need to scale up bigger. So I'm going to talk about, each one of these points. So you're going to start with a virtual machine. Then you're going to go to your web portal. I'm going to show you at the same time where you will go to the Jupyter Hub. And again, just to highlight that TACC is there. There's a lot of resources there. I'm still working through getting all that into the documentation. So let's get started and actually going into DesignSafe. So the way you would access the virtual machine as well as the web portal, and that's the focus of today's workshop, is you're going to go to designsafe.art minus the little line ci.org. I think you just Google it, or probably already have it on there. Make sure you have an account, and then there you go to tools and applications. Within tools and applications, if you want to access, the OpenSees directly, you go to simulations and you select OpenSees. If you want to go to Jupyter Hub, you actually go to analysis tab and then open up the Jupyter Hub. I know that this workflow is going to be redesigned, but no matter what you call it, I want you to have a visual as to where these different things need to lie. So if we now focus just on the OpenSees part of this for the interactive machine as well as the web portal, they're actually accessed from the same place. This is in simulation in OpenSees, and you just have a pull down menu. You see the 3 objects that I already presented. One is the interactive virtual machine. One is the OpenSees Express. This is where you submit, these last 3 is you submit jobs to these 3 through the web portal. And the very first one is interactive. I've redesigned what's here. There's a lot of instructions and documentation and a nice introduction. You almost don't have to know anything. You can just read what's here. And there's a good description of these. In the introduction here, in this very tab, if you click a few different buttons, it gives you the specs for each one of these different machines, as well as there's a detail here that you open up the instructions. Make sure you read them at least once so that you actually know what's there, but then you just don't have to read it for, check it once in a while to see if there's some new thing. Okay, we'll change the color if instructions have changed. And so there's a lot of ready resources just in the very top tab here for accessing OpenSees. If you open up the virtual machine, so you select the VM, as I've already described, it's a little Jupyter, you see it even says Jupyter Lab, but the Jupyter Hub on DesignSafe has a lot more items. Okay, it's got MATLAB, it's got a lot of other interpretive options. Okay, this one here is intended for OpenSees itself, and it's got OpenSees preloaded in it. And as you can see, it's got the Python options as well as text editors and a terminal. So it's all here in this tiny little window. When you load up the interactive machine, give it a second, and then it gives you instructions to connect to it. Okay, and this machine is up until you kill it. I think it may have a time limit. We're still trying to decide whether to use time limits. This is a shared resource, so use it carefully because there's others that are also sharing this resource. But I think there's enough resources for everybody to be able to be cool if this gets used too much and we need to build a new one. Okay, so this is a really great place to start for building your models. I'm just zooming in here and I want to highlight the different parts of this. And many of us have worked with Jupyter Lab. So I like that this interface is something that's already familiar to others. There's a navigation. Okay, you can actually move within, you see there's the My Data, there's a community data. So you can just navigate easily to your working directory. You can double click on files, you can duplicate files just in this navigation window here. You can upload files from your computer if you want to. And so it's a very simple project task. If you need to upload a lot of data, then do it through the data depot. Okay, but this is great for uploading your very first example one file, for example. There's different file editors. I just use whatever double clicking on a file gives me. And then there's the terminal here. This is what you're going to go in to run OpenSees, as well as if you're doing it through a Jupyter notebook. So if you're using OpenSeesPy in a Jupyter notebook, you can do it here, or you can have just a simple Python console that doesn't have all the weight of a Jupyter notebook. So this is, as complete of an IDE as you need for running OpenSees. And so if we pick the two, if we look at the file editor and the interactive terminal, the file editor, you just double click on a file. As you can see, I've navigated to the folder I want to go. You can actually edit the file real time. In the old days, you had to connect through a command line, and then you need to use a special editor. Maybe you could use VI. Oh, I used to use VI in the 80s. So, but now you can actually edit it through a regular text editor, and then you can have different tabs. So you can have one file in one tab or many different files in the tabs, and then you can have your terminal in a separate tab. So you can go back and forth between editing the file as well as just running it and adjusting it and iterating on it. In the terminal, you can run all these, you can run OpenSees just by command, running a script, and you can also run SP and MP. And so here's an example here. You log in. If you navigate your navigation window to your path, it puts you, and then open up your terminal, it puts you right where you want to be. Maybe that's where your input file is. You just type OpenSees, and then you can actually manually, just like you do on your desktop, type wipe and model and back and forth and do it interactively, even though that's, not the best way to do it, but it's a good way to just do some simple tests. Or you can open up OpenSees and then you give it your input file and then it runs it for you. And, I like to put little things that say what it's doing and it's done. Okay. And so it's great because, hey, I had no errors here. So that's perfect. Now you could do the same thing with MP and SP. And this for me is awesome because I was trying to get to know OpenSeesMP and I was submitting files through the web portal. And then by the time I got to see the output, it said, oh, there's a typo, there's an error here. Okay, and so it was really important for me to be able to run OpenSees, the parallel versions, in this interactive mode. And so you see here that you call up, and these are simple commands and they're documented, and you say, hey, run OpenSeesSP with 6 cores or 6 processors, and this is my input file. And same thing with MP. And then, this is whatever output you tell it to output. This SP finished, and same with this one. Okay. Now, remember the number of cores, you have a certain amount of memory, and so you don't want to use up all the cores. If you have a memory intensive model, you might want to use fewer cores and therefore dedicate more memory to each core than using, oh yeah, I'll just use all the cores that I have available, okay? So that requires a little bit of thinking and planning. Why run these here? And as I've already kind of giving it away, it's great for error checking, okay? And so I put in I forced an error into my script and I can see it right away in my output. Everything looks good, and then I scroll down and it tells me I have an error. So this is a great place to start building your model and testing it, okay? So the notes on the interactive machine are very important because it may not be much faster than your desktop, okay? If your desktop can run the script, all right? So I don't have MP nor SP on my desktop. And it's also a shared resource. So maybe doing everything on my own computer may be faster, but hey, to me, it's another machine out there. So maybe I can have some things on my desktop and run things there. With my data, as I've mentioned many times, I've expanded my storage space. I've got access to DesignSafe resources for pre and post processing, and my runs generate so much data and I work from home. And so the upload of the data is just intensive. And so there's a lot of advantages to getting started right away from day one on this virtual machine. And remember, on the virtual machine, you can also run OpenSeesPy. And as I've mentioned already, you can do it in the Jupyter Notebook as well as the Python console and in the terminal. And so you can do different things. The console is kind of nice. That's on the right-hand side. It even has the graphics. The terminal won't show you the graphics. Or you can do some nicely formatted Jupyter notebooks as well. So you can upload your own Jupyter notebooks if you want and run OpenSeesPy there if you want, okay? And this can also be run, of course, on the Jupyter Hub, which brings us to the next resource. The Jupyter Hub, as I've already talked about, it allows you to integrate OpenSees into your workflow. You can prepare your pre and post processing and submit it right to HPC, okay? But now we're gonna, that takes care of the Jupyter Hub, but now I gotta jump back into the web portal, which is really the most powerful, or it's the other most powerful resource that you have on DesignSafe. This is the rest of the selection that you have in the pull-down menu in the OpenSees simulations. You can scale up and speed up your projects. You can submit your sequential projects on a virtual machine. It's not the same virtual machine as the interactive one. This is a separate machine. And so you can submit your sequential jobs there, or you can submit your SP and MP jobs directly to HPC. And you upload your script and it sends it to you and it does everything in the back end and runs OpenSees on Frontera. And because this is for relatively small jobs, there's no need for an HPC allocation. And so you can just go in and run your models. OpenSees Express, as I said, it's a separate machine. It's a very powerful machine as well. It's 24 cores, 48 gigabytes It's a single node, so it's a virtual computer. And remember also that one is a shared resource. The SP and MP that run on 2 nodes that have 56 processors per node, 192 gigabytes per node, really scale up your resources, okay? And you don't share that node, and therefore you really have a lot of power to you. And as much as now you have to kind of wait in a queue, the runtime is just so much faster, especially if you've prepared your script ahead of time, that it's really worth the wait in the queue. And uploading your scripts is easy, and you can actually upload a few different jobs if it's a relatively large project itself. Okay, and so now you can have more than 2 nodes, but of course there's limitations, of course, per user. And so the running OpenSees on the web portal is fast. All OpenSees applications are there. I'm working to make right now, you submit tickle scripts, but hopefully in the next X months, you'll be able to OpenSees to submit Python scripts. That's what I'd like for OpenSeesPy, but that still needs a little bit of work of making sure that the integration is automated. The only drawback of submitting jobs to the supercomputer, no matter what, is because it runs faster and therefore it needs to move the data to the nodes. You don't have access to the results until the analysis is finished. And these wait times can seem an inconvenience, but the ability to run many of them really affects your total job time. And so make sure that your script runs before you submit it, and that's where the interactive VM is for. And as I said, there's no need for allocation, so you can just go on and start your project right away. Very, very important, though, is make sure you read all instructions and all documentation first. Okay, that's in the, when you go, this is the dashboard that you have for your jobs. I've shown you that on the right hand side here is the status of many different jobs. You open up the instructions, it gives you the instructions, and this is the form, and I'll show you things about this form. This is the form that you submit for the jobs. It's actually pretty trivial and well documented. It's documented here, and it's very easy to fill out this form, so it's not asking for anything. I've put here a workflow, and it's kind of a little bit of details on here, but it's important. So first, import all your scripts and all your input files and all your data, such as grab motions, into the data depot. You navigate to the portal. And first you make sure that you're logged in. I guess I switched the order. Oh, that's supposed to have a tab. So you log into the DesignSafe and then go to DesignSafe, all the way to OpenSees. You select the OpenSees application you want. All the inputs are described here and described in the application. You just have to give it, the input directory, what is the main script, maximum runtime. The job gets killed, so I always just put in the maximum runtime that I'm allowed. Again, I'm not sure here, but sometimes if you ask for too much time, oh yeah, it says it here. Shorter runtimes result in shorter wait times. So make sure you estimate and you don't overestimate your runtime. But if you underestimate it, your job gets killed and it's very frustrating. Okay, and so you got to kind of play a game on that one. You specify the output directory, and you want it to be not in your main folder. You want it to be separate, and then you bring in the data. You give a name to your job, which is important because on the right-hand side, you're going to have job statuses. So you want something that, if you're running more than one job, use something that's descriptive. And then if you're using the parallel application, it asks you for the number of nodes and number of processors. Again, why not there's total limits on how many nodes you can use, but then if you're using the nodes, you might as well assign it as all the processors, right? Well, but be careful. If you have data intensive or memory intensive project, maybe use 4 processors so that they can use more memory. You submit the job, you wait for confirmation that the job has been submitted, you check your job status, and once your job is finished, you look at the output. there's two things you need to look at: is the error data, which is the error file, which is really your echo, as well as just making sure that all the recorders are complete. If that job is run to your satisfaction, then you can move the data from the archive to your work folders. And then you can do your post-processing. So it's pretty, it's a lot of words, but it's pretty nice flow there. To look at your output, these are just little screenshots. You click on more info, and then you say, okay, it gives you information as to when it was run, how it was run, or what status it's in now. If you're happy with it, you go to view the output, and then that takes you to the data depot. Okay. In the data depot, this is just a screenshot from the documentation. I give you a little bit more information. It shows you the path where this data is. You want to open the echo file. That's where if you have errors, it will tell you the errors. Look at the documentation in DesignSafe, and I show you some interesting things about it. And then all the input and output is in this folder. Make sure you move it to where you need it, and then do some post-processing. Okay, again, you could do your post-processing in Jupyter Hub. Jupyter Hub, we've talked about it already. I'm not going to go into the details on how to submit jobs to the HPC. Maria Giovanna had done a really good video on that already. And so right now I'm going to refer you to that. That's in the, and there's a lot of sample files in DesignSafe as well. So I haven't quite gone down that rabbit hole myself. The TACC is the best way to do it when you have a really, really large project. But that's beyond the scope of what I'm trying to do right now in this workshop, especially because there's lots more coming your way on this. I have some crazy ideas of how we can automate things a little bit more, but there's actually there's already a really nice workflow that's in place. So you're not really working at the terminal itself. You're at the terminal submitting jobs in batches. So there's a whole interface set up for that already. And Wen Yang, who is working on OpenSees and TACC, he's really experienced with being able to run many different projects. So there's a lot of support that you can get at DesignSafe on this. Of course, I made another table. And I don't want to go into the details of this, but it talks about, the different OpenSees applications and the different platforms and how you can run them, and what is the optimal way and recommended ways or things to keep in mind as you run each one. There's always a balance of your time versus computer time, and really making things optimal at both levels. And so that kind of brings me to the end of this first part. Well, the end of the big talk on OpenSees and in DesignSafe in the infrastructure, in the cyber infrastructure. It's just about scalability. It's seamless scalability, seamless integration. You've got your input file here. You can run it from wherever way you want to. It's still one input file. For me, I have a lot of hard time keeping track of, what is the latest file, what should I be working with, and did I upload it, did I not upload it? And so everything there just saves you a lot of just time yourself in managing your projects. And that's what I mean by efficient in scalability, because it's just every little fat that can be trimmed at every step of the way. If you do it all within DesignSafe, it really works really well. And so this is a big picture overview. A lot of the things that I've talked about, you can find them in the user guide. There's a lot more words there, as much as I've used a lot already today. Again, it's broken up into like introduction to OpenSees on DesignSafe and things to keep in mind, my little decision matrices, talk about the different OpenSees applications, as well as the different OpenSees platforms. I'm still working through the more advanced features for the HPC integration. And with that, I'm happy to do a live demo, but I would actually like to pause here to see if there's any questions on this, because I've hit the hour, and so I want to make sure that we do this, because the live demo is really not as important as being able to answer questions. So
Thanks a lot, Sylvia. That was great. That's so much information. It'll be good that this is recorded, right? So we can watch it back and pause and everything.
yeah, do it at like 0.75 speed, but or 1.5 speed, depends on what you like.
So if anyone has a question, maybe this is a Zoom meeting, not a webinar, so people can unmute, but maybe it would be good just to raise your hand so that we can call on you so that we don't have people talking over each other. Andres, yeah.
Hi, can you hear me?
Yes.
Thank you very much for the presentation, Sylvia. It was great. There's a lot of information. I had a question just really quick. Could you repeat what you said about the memory intensive model where using less processors is actually faster than using more, because it's something that I'm facing right now in an SP model.
Yeah, so I don't know which slide to go to, but I'll just stay here. So remember that you've got many analyses, right? And you want to run them in parallel. But each model has a matrix. All OpenSees is putting data into a matrix and inverting that matrix and solving the equilibrium, right? And so inverting a matrix takes memory. It needs to keep, it keeps track of, and especially some material and some elements actually need, the state, what is the current strain, what is the current damage parameters, right? And so every element has its history that it must carry with it. So if you've got a large model that has a lot of elements that have a lot of history parameters that are with it, and also you have just a really large matrix that needs to be inverted, so that's a big model itself, and so it's data intensive because it needs to remember all the data that's associated with it, even the recorders and everything there. And so it's if you hit, if I run a really large model on my desktop, well, on my laptop, let's say, at some point it's going to say, hey, you've got weight, and I've got billions of elements. It's going to hit a wall, right? It's going to say, hey, I don't have enough memory to keep track of all this data. And so now shrink that into something that's manageable. And so maybe my computer can only run one such model at a time. Or it can only have, if one model requires, a certain X gigabytes, it depends on how much memory I have in my computer to be able to run, 7 analyses. If I run 14 analyses, I'm doubling the requirements on my memory. And so don't run, 56, you've got 56 processors. Don't use all 56 processors if you have a relatively large model. Maybe only run, because now you've got 192 divided by 56, and that tells you how much memory is for each analysis. And so you kind of want to share the resources and be able to give enough memory to each analysis. Of course, the memory gets managed, and maybe there's going to be some points where it requires more and some points where it requires less. But my point of it is, don't forget about memory and being able to keep track of everything that's needed. Otherwise, it may just even slow down your analyses, and now you're back to square one. And so make sure you assign the proper resources to the analyses.
So,
thank you so
Sylvia,
much.
we have
That's
a couple
really
that came through the Q&A. Maybe, is there going to be a PDF of the slides available? I know that this is recorded, but PDF too?
Yeah, yes, definitely.
Okay, great. So I will put yes. And then, sorry, Andres, did you have a follow-up question?
Nope, that was it. Thank you very much.
Okay, good question.
Oh, okay.
Thank you.
Okay, thanks. And then there's a question, if we have a user-defined material, how can we use OpenSees and DesignSafe? So I'm assuming that means that user has developed their own code and compiled OpenSees from source on their own machine, I think.
Yeah, so one is you can work with the folks at DesignSafe to see if you can bring something and have it compiled there. The easiest way to do it would be to compile it in Python and then just pip install it and run the Python version of it. But if you need to run the other versions of it, you need to work with the folks at TACC. And I think there is a way of being able to bring in your own local version of it, but you need it to have it compiled in-house, just because that's the configuration on processing.
And Sylvia, do you know how often we update the OpenSees versions that are available on TACC resources? Like if a user commits a material model and it gets ingested into a new version of OpenSees, how long might that?
I'm trying to get that sped up. I don't want. I've been pushing Frank to produce OpenSees executables more often than every few years, and so I think we're getting, now that he's resolved the whole makefile and everything, we're hoping to have every 6 months an update and have DesignSafe be consistent with that. There's a lot that goes on behind deciding, for a new version of OpenSees. And so Wang Yang is trying to stay along with Frank. But that's something that we've just started now to be a little bit faster in getting things out to the public.
All right, thanks. Let's see, Omid, you're next. Go ahead.
Oh, hello. Thank you very much for doing this, Sylvia. I just wanted to ask you a question. When I do these models, like doing incremental dynamic analysis for 12 frames, 20 frames, something like that, it usually takes for 2 months when the model is huge. And at the end of the analysis, I understand that if I had that recorder, I could, the one recorder that I haven't defined, I could interpret the results much better. And then I have to put the recorder, and again 2 more months. I want to ask you, because you said that you have access to huge storage because of the supercomputers and everything. Is it possible to save everything in the model? For example, in Abacus, this is completely possible in the post process. I want to ask you if this is possible in OpenSees.
So yes, you can. So this is more of a, so one is, I'm pretty sure there must be some limitations on the storage space, but I think you're talking about real time being able to dump everything in OpenSees. Yes, you can. Of course, you write the recorders. You have to tell it what everything is. Somebody in Abacus wrote a script that it runs internally that outputs everything. In OpenSees, you would have to write it all out. I think the MPCO recorder does that, and it may do it efficiently because it uses an HDF5 file. But my recommendation is just be careful, because as I said, the output, it takes time. It will slow down your analysis. And so if you're not outputting much and it's 2 months, if it takes 2 months, it's going to take twice as long with that much more output, because as I said, that's what takes time. And so this is why I recommend that you run a small scale. You get to know, look at your results in small scale, look at your results, think about what you're seeing in the first place, so that then you can decide what the proper recorders are. A lot of stuff can be done in post-processing. So for example, for fiber sections, if you have your axial force, moment, and curvature, you can rebuild it in post-processing so that you don't have to output all the fiber strains. If you want to output everything, make sure that you have an efficient model, that you don't have fiber sections with 7 integration points and 1700 fibers in every element of your structure. So yes, you can output everything, but just be careful. I would just try to do something a little bit more intelligent than that, in the sense of think ahead of time before you act, which is strange for me to say, but yes. So that if it already takes 2 months, then don't make it take that much longer. And a lot of the data you can do in post-processing.
And there are memory limits. Tim can correct me if I'm wrong, but I believe everyone gets a 5 terabyte allocation when you sign up for a DesignSafe account. If you go higher than that, maybe you would have to pay for storage, but I think there's some flexibility there, right, Tim?
Yeah, as long as you're storing data on DesignSafe, yeah, you can bring or generate and save through simulations, about 5 terabytes of data.
Yeah, and
You're
and it's
correct, Scott.
right, and there's connections in the data depot to Google Drives and other drives so that you can move data elsewhere to your own personal storage, and then transfer what you need. But again, one is its memory. The recorders take up memory. I wouldn't try to dump everything out because you may not need it, and so think ahead.
So the next question came through the Q&A. Masashi Kishimoto asks, is there a need to write the script defining your model in a particular way for it to be able to run on OpenSeesMP? Or do you just write the script like a normal old OpenSees script and OpenSeesMP knows what to do?
So OpenSeesSP knows what to do, except for that you have to, and if you look at the documentation, and there's a lot of things about, I mean, this is not just a DesignSafe issue. I mean, this is just about OpenSees itself. So OpenSeesSP, you just have to specify the parallel solvers. For OpenSeesMP, you write your script in Tickle or Python, however you want, but you need to know, hey, what is your processor, right? Because all the processors are running the same script. And so if you don't assign any jobs to any particular processors, you're just going to have it run 17 times or n times, however many processors you have. And you've got to be careful, because what if you're running the same script and you're outputting to the same file? I should have put that as a big notice to be careful. So yeah, if you look at examples and other videos on how to use MP, it shows you that you first have to get the number of processors, then, and there's scripts in the documentation on this, and then say, oh, if your processor is so-and-so, then you do this. If you're different processors, then you run a different analysis, and the same thing with the allocation. So the script is the same, but there's additional things you need to do to assign jobs.
Yeah, and we do have a video by Maria Giovanna that Sylvia mentioned that talks about how to use OpenSeesMP and specify a list of ground motions if you want to do a parameter study and that sort of thing. That's in our YouTube channel that you can find through the DesignSafe Learning Center.
Yeah, and I've also put it on there, and I'm planning to do a little bit more on more things as I get to know OpenSeesMP to be able to do things that are a little bit more advanced too.
All right, Franco, your turn.
Hi, thank you for your presentation. I have a specific question. I'm using OpenSeesPy to run uncertainty propagation analysis and parametric analysis, but I'm using the parallel computation tools that are available in Python as external tool there. Can I run this on DesignSafe or not?
Yeah. Yes.
Okay.
What are you using? What's the tool you're using?
I'm using
concurrent features.
This multiprocessors pool. Actually.
Okay. Yeah, so I would look into concurrent futures first. It's newer than the multiprocessor, but OpenSeesPy. Now, by doing that, you're going to an external library. Okay, and so remember there. So yes, you can do this on OpenSeesPy right now. You can run OpenSeesPy on both the interactive as well as the Jupyter Lab. And so pip install what you need. I think some things may already be there. If they're not, you need to pip install them. But again, if you're going through an external library, there's a lot of expense in managing the pool. OpenSeesPy has the MPI internal to it. And so that makes it much more efficient because it's internal to OpenSees. And so, but I'm trying to get that version of OpenSeesPy into the DesignSafe. So yeah, right now do what you're doing. I tested it, and that's how I run my parallel OpenSeesPy analyses.
Okay.
And Franco, I'll add one thing. If you're using the DesignSafe Jupyter Hub, there are only 4 cores available for parallelization. They limit the number of available cores there. So
Oh,
you can specify an MPI job with more than 4 cores, and it will actually run slower than if you only specified 4, because there's some overhead from all the MPI communication that happens. So if 4 is enough, that's great. If not, you could go to one of the bigger systems, but then that would require you to write your scripts in Tickle instead of Python, right?
oh,
Well,
yes, that's the problem.
but he's
Okay.
not running it through. So that's a good question. I'll look into it, because he's not running it through an MPI. He's running it through a Python libraries. And so that actually, the way it's configured right now, it allows you to use all the cores. Just be careful, and we may need to set limits on that. But yes, I guess there's limits on the MPI, but I don't think you're running it through MPI, right? You're pip installing this multiple things. So it's a different system.
Yes, I'm taking like externally
Yeah.
the parallel computation.
Yeah,
for
because you
some.
could.
Yeah.
Yeah, so that's the other way you could do it, is you can run MPI that calls Python through the MPI, and then that could manage the different jobs, and so then you would run it just like OpenSeesMP, but you're actually getting. So I'm working through all this to make sure that it's not so confusing. There's ways, so there's like 3 ways that you can run it in Python. And that's why I'm putting on hold on that, to make sure that I get it all resolved and documented, so it's not so confusing.
Okay. Thank you.
All right, and then we have a question from Ali in the question and answer. So incremental dynamic analysis is a time-consuming analysis. Please explain how the DesignSafe can reduce the time of analyses. Please compare the analysis time for a case study structure.
Okay, so first of all, you shouldn't be running IDAs. You should be running spectrum consistent, hazard consistent ground motions. But okay, so DesignSafe just allows you, when you're doing an IDA, it depends on how you're running it, right? So you can either just keep on just define a set of scale factors, right? So you define a set of ground motions, you define your set of scale factors, and you run the analyses. Doing this on DesignSafe is faster only because it gives you that many more resources. Therefore, you can run that many more analyses in parallel, because you got 56 cores per node. So you got 100 and I don't know what that is, 112, which is more than my gaming desktop has, and the space. So if you just run them in parallel, it's that much faster. Memory is bigger as well, so that means you can run that many more at the same time without having memory problems. Now, if you're running IDAs where you're looking at the results in the previous one, which is what I was talking about earlier as well. So then some things need to be run in sequence and some things can be run in parallel. And DesignSafe is just giving you the platform for you to write the script to run it the way you want to. They're doing the hardware. You got to write the script, and comparing it is hard because it depends on if you have convergence issues and have to iterate, depends on the size of your model and things. So DesignSafe is just giving you a much bigger platform to run these on for IDAs or anything else. I hope that answers.
Sylvia, I have a follow-up question. You mentioned that running jobs through the DesignSafe portal to OpenSeesMP, you're limited to, or SP, or you're limited to 2 nodes, which is 112 cores on Frontera. Is that a limit that's built into the OpenSees builds, or is that a limit that's imposed on the community allocation that people use to run these scripts? And if they had their own allocation, could they run it on, say, 1,000 nodes or 100 nodes or something much bigger?
Tim is getting very giddy about this question right now. So right now, the way it's configured, the web submit is meant to be fast, and that's why the more requirements, the more you ask, the more you're going to have to wait. And so the way it's configured right now is, let's make it big, but not that big. So you've got the 2 cores. If you need to run something bigger, you might as well go directly through TACC. But there are plans in the future to make it a little bit more turnkey. So then you say, okay, I want to run OpenSeesMP, and then they're going to say, what configuration do you want? Do you want to run it in the small queue, which is 2 nodes, or do you want to run it in the regular queue, which is X nodes? And there's different ways that there's allocations or configurations of the nodes in TACC. And so eventually that's going to be, because I'd like to be able to do what I had to script and wait and go crazy and checking jobs, to be able to make that accessible through the web portal. So stay tuned on that. It's getting bigger and exciting, and versatile is really, again, that scalability, bringing in at every level of the design of the cyber infrastructure.
So yeah, I just wanted to make the point that, these OpenSees builds themselves are not limited to 2 nodes. That's just the way that we're running it through DesignSafe right now. If you need more, that is possible, right? You just have to have your own location. Yeah.
Well, yeah, and you go to TACC, or you could submit them through the Jupyter Hub. Would be the way to do it, instead of going through the web portal. And there's use cases on that. So that right now is actually possible. If you have an allocation, you go through the Jupyter Hub if you want something a little bit more automated than just like the web portal, but with a little bit more control.
So Omid, is your hand up again, or is that from the previous question?
No, sorry, it's from previous question.
Okay, no problem. So Bijan, your turn.
Bijan.
Hi, Sylvia. Thank you. Thank you for this great presentation. I was not familiar with DesignSafe, and now I understood it. Thank you so much. I have a question about the OpenSees Cloud. Is DesignSafe about OpenSees and OpenSees Cloud providing same platform, same activity for us, and doing same action, or they are similar to each other, or there is some differences between them?
They're different. That in concept they're the same, that you request certain nodes and configurations. OpenSees Cloud runs on AWS, and it doesn't. OpenSees Cloud gives you an image, and I don't know enough about it. Okay, so but it gives you an AMI, and you run it, and it's different because it's a pay-per-use type of service. DesignSafe gives you other ways, or many different ways, that you can submit your jobs. DesignSafe integrates the data, integrates the whole data depot, integrates Jupyter Hub, other things in it. So they're just different tasks, different ways to approach OpenSees, which again is just AX equal B solution. So they're both ultimately doing the same task, different target audience and different scopes though.
I guess on OpenSees Cloud, AX equals B plus money, right? Something like that.
Yeah, but money is time, so
yeah.
Yeah.
We did get a question as a follow-up to a previous question here in the Q&A. So can you briefly explain how hazard consistent analysis differs from IDA and explain its benefit and relative accuracy?
I would love to, but I can't. It's way beyond the scope here. So Google it, look into it, and it's a fascinating thing. So you'll find different people with different opinions on IDAs and hazard consistent. You can look at the work that Jack Baker has done on his stripe analysis. That is something you should look into if you really want to optimize your analyses. But yeah, that's a different hat.
It's all related to ground motion scaling, though, fundamentally, right?
Well, it would be, but yeah.
I think that's it. Hopefully I'm not missing a Q&A or a chat. So let's see.
Okay, I think we're good so what I want to do, and I'm glad we kind of answered
Yeah,
yes.
are you going to do your live demo, or should we wrap?
I want to
it now?
just do a quick demo on this,
Okay.
just if people want to stay on or not. I think it's worth it. I wanted to make sure. I do better presenting to people than to myself, so I wanted to get this documented. So I'm happy to have this. Tim is answering in the chat to Bijan that DesignSafe is prepaid by your tax money. Therefore, there are no additional costs to running DesignSafe. So yes, and then I should have said that, but it seemed, yeah, it's already paid for because it's a big investment from NSF. So yeah, there's it's a really nice service what DesignSafe is providing to you from your tax investments. So yes. I think that's all. The other stuff is too many words that I can't read. But yeah, so Tim's got some really useful information in the chat, so make sure everybody has a look at that. So I want to do the live demo just kind of quickly, and let's see how live. I wanted to separate it just because live demos don't always go the way you want them to, but let's give this a try. Okay, so I want to do 2 live demos. Are people on still, or have I lost everybody? Okay, we lost a few people, but we're good. All right, so I want to show you how to use the interactive VM and how to submit a job on the web portal. What we're going to do is I want to kind of give you an outline of what we're going to do because it may not work out, and I've shown you already before. Steps are easy. You log in, you get to DesignSafe and OpenSees, and then you read the instructions. You select, at this point, this is the same. Now you select which OpenSees you want to use. We're going to use the VM. We're going to click launch. We're going to wait and connect, and then we play. Okay. So I should have practiced this. Okay. I'm going to go to simulation, OpenSees, and here I am. Okay. So I've logged in. I'm still sharing, right? So now we're going to read this as I was showing you. It's got little, divs and details that you can read and open up. My Zoom stage on this is strange, but anyways, you can always zoom in and out with your browser to really be able to read things. Okay, so we select the interactive VM and a new little specific window comes up. Oh, I need to make sure that these links go to the right places. It's difficult to keep everything synced. Now, it's not asking me for anything except for a job name, but there already is, if you click here, there already is a job name and it's green. And I'm happy with this because you can really only run one interactive job at a time. So you don't have to do anything here other than just click launch. Now wait, and wait. You see little things are popping up. You got to be patient. The first time I caused chaos because I didn't wait and I was like, whoa, nothing is happening. Okay, so that's why I wanted to do this live. Now the machine, because they got to go. Somebody's going to go and get the machine and put it together and link you to it. So it takes a little bit of time. Now you can go ahead and click connect. And that opens up a new tab. Be patient. And then this is exactly what I showed you before. In my little screenshots, I go here and I'm going to go to my data. I'm going to go to, see, I have a lot of stuff from way back when. I got my folder for OpenSees Tickle. And now these are all the different things that I can look at. And I can look at, where's my example 1 file? So here's my example 1 file. I can edit it if I want to, do what I want. I could do little things. It's not the best editor. So if you really, what I often do is I do edit in something else. Because you can't do the full global replace and search and replace. But this is darn good for being right here. Then I go back to the launcher and I say, okay, open up the terminal. And you see it's put me exactly where I want to be. So I can type OpenSees. I don't have to do anything. I just type OpenSees and I'm there. Wipe is the easiest command to test and that works. Or I can say, even there I could have said source, or I can see OpenSees and I just click up the arrow and then tickle the tab. Oh, gives you the options. Oh, that's okay. So it's not the regular tab. Anyway, so what I like to do is I will copy this. And that's what's nice. It's like, poof, there it is. Did that work? And that worked. Okay. So this is the demo on this. Now you could just turn on, oh, and this is, you know, if you want, you can upload a file. It opens up and you can go and upload whatever file you have. I already had it on there. You can, there's like lots of little things here. You can open up the launcher again and you could do a Jupyter notebook. And so what you could do is I can go here, copy all this and put it all into my Jupyter notebook. Okay. Now, of course, this is a TICL file that I'm putting it into a Jupyter, so it won't work. But I just wanted to show you this. Okay. Very important. All right. Once you're done with your job, oh, I can show you how to run OpenSeesMP on here. So I have a file that's just simple MP. This is what it looks like. You see, it's got all the ground motions and the script of, no, where is it? Something. Here's the PIDs and it checks. And so it's just my way of coding this. So now I can go back here and you need to tell it to run it through the MPI because the MPI is a like extra program that loads things up, a certain file in parallel, which I'm excited about because it means I could do it with other things. So you could say MPI exec. And I could say 4 nodes, NP is 4 nodes. I can say OpenSeesMP, okay, it's in there. And then I say simplemp.tcl. All right, so I'm saying, hey, OpenSeesMP, run this TCL file. Maybe this TCL file may call other files and do whatever it wants. So this is the main file with 4 nodes or 4 processors. Poof, and it goes and look through and I got no errors, which is good. Yeah, this warning is it's a stupid OpenSees thing. But anyways, so it tells me which PID it is, so which processor is doing what, and they're all accessing different ground motions. Okay, and so this is really nice because it's a great way. Now that I know my script works, I do it for 4 processors and a limited number of ground motions. Now I can upload this over on DesignSafe on the web portal and run it. And so maybe we can do that. Okay, so now I'm done with this machine. Now I could leave it up and just let it build up garbage. And I think maybe at some point it's going to get destroyed. There's some like thing here that you say log out, shut down, but I'm not quite sure if those really work. So what I do is I shut down here. Okay, but you see I could reconnect, but I close it and then I look at my job status and I see that this job is still running. And so you go here. I find this to be the best way to do it. I can connect or I can just delete it. Okay, and so that's the way to end that job. And it's done, and I think that's what popped up here, or maybe not. So it's done, and that's the way you close an MP. Excuse me. Oh, this is finally done. I sent something to run, and it's done. Okay, so that is how to run the interactive VM. If I go back to this now. In the interactive VM, remember you can loop through this and edit your script and save it. Make sure you save it and run it, you know, back and forth between the 2 little tabs. If we go to the web portal, same kind of processes. Make sure your script has been uploaded, you know, or you already have it. You've been playing with it anyways. Read the instructions and then. The instructions seem simpler because you select the MP, you fill out that form, you click run, then you wait, you check your job status, and that's kind of what takes a little bit of time. If you want, send another job, a separate, different job. And make sure you read in the documentation about multiple jobs because it duplicates your input file, you know, your folder and things. So you got to be really careful about the data management, which I think is an excellent way of managing data. It just requires you to do a little bit of cleaning up at the end. And then you move your output when you're done and you post-process, okay? So this is my last slide, but I'm going to switch over, okay? So if I go to here, Now I'm going to pick OpenSees. So let's say that I'm going to reload. Okay. So I'm back here. All right. I start from scratch. I read my instructions if I want to learn a little bit more about all the input in the form. I've tried to move the input from the form itself to here. So let's go to MP, which requires a little bit more, has more questions than the Express. Okay. So now things get interesting. What we need to do it is tell it, hey, which folder are you going to clone and put over in the node that's going to be running? All right. So that's why you select the input directory first. So you can either like write the whole path here, or you click select, and then that brings you here. And I'm going to navigate. I don't want that root folder itself. Here's my OpenSees demo. And then this is the folder that I want to copy. So be careful. You don't want to put too much stuff on there, because then you're moving way too much data back and forth. Okay, so always make sure you've got a lean folder for your studies. But this is what I'm going to use. So I'm going to say select, and magically that path that I didn't really know is there. Okay, then you need to say within that folder, what is the script that is going to be running? So remember, all your ground motions and all your recorders, you can't send them to pass back and over. All right, it needs to be in that folder that we have cloned. And so the main script, now I'm going to go into here. So I can select it on if I need to. No, I don't need to. Let me try this. And then there was a simple MP, right? So this is the one that I want to copy. I think I just need to drag it and drop it. Poof, there it is. And it gives the whole path. I think even if you just write in the name of the script, so I could do that. Let me just copy just in case. But I could just say simple MP, because that is in that folder itself. Job details, runtime. As I said, this thing's maximum is 48 hours, but the more time you ask, the more it's going to make you wait. So maybe we'll just ask for 2 minutes. And I think right now you have to do the whole format. Okay, it's green. I did it right. So I only want 2 minutes. Job name. It has a job name. It tells you what the machine is. And when I started it, keep that unless you're doing many jobs. Okay. And so maybe you could call it, test 1, but keep this data in there. Okay. Because it's just good for you to know the metadata. The archive location, let it be. Okay. Use what they give you, because that already has the job name. And so I already have a recognizable way. Don't put it into my data. If you put it into my data, which is your folder, it's going to create a folder inside your folder, which then you can create. It's a mess. Then the number of nodes, 1 or 2. If you go more, it gives you an error. Yay, that works. And again, number of processors, maybe you might want to go to, 7 processors. And you're gonna, well, let me make it bigger. And then you click run. Again, you wait, little things pop up, and it tells you that the job, there's my test 1, has been uploaded. Now you gotta wait. You can refresh. You can get more info, and it kind of tells you, hey, it's being moved from staging inputs to staging and blah, blah, blah. There's no output to see. Remember, you don't want to see, you can't see the output until it's done, because it's attached to some node somewhere. Now, let's look at if I have something that I finished. So that one's cute. Okay, so here's a job that was finished. Okay, so I'm going to click more info. That job is finished. It tells me the information. I can delete that whole job and folder, but let's go look at the output instead. I showed you the screenshot. This is a clone of the folder, and it's a clone, not what it looks like now, because maybe I've done other things in that folder. This is what it looked like when they cloned it over, and it's got all the recorders in it. But the first thing you want to look at is this, and it's called the error, but it doesn't mean that you have an error. It's just the echo. And if you click it, it's important to see, this is kind of like the beginning is kind of junk, not junk. It's important to somebody who understands it. But now it's saying, oh yeah, so this was one when I was testing whether the MPCO recorder was working. It is now, but you see, this tells me just like when you start OpenSees and it echoes, and this is the error. It's saying, hey, but this took me, 17 hours to get this information, or 2 hours, or it actually didn't take that long because I didn't ask for so much. But you see, I found the error, and therefore I'm not going to have any data, and I need to go back and edit my script or fix it. Okay, look, there's little things that are popping up about my job. And so then this is where you would find the recorders and any data you wanted. Now, if we go, and you see we're in the data depot. If I go back to here and I close this, oh, it's cute. It's still running. But you have an idea of what you need to do. So when you're done, move your files over to your working directory, and you can do your post-processing, whether you did it through MP, whether it was in your interactive, or any sort of analysis that you had done. You move to your post-processing. And I think that's all I wanted to show you today. So if there's any questions on this, I'm here. And if you want to learn about OpenSees itself, if you go on my webpage, it links you to courses that I have on OpenSees. So for those of you, a lot of you guys stuck around. Thank you. Any questions on this? Or more questions? I think you're free to just speak up if anybody has a question. But it was so clear that I think we're good.
Sylvia, thank you so much. I do want to add, I added another note in the chat about our user support, and we do have a Slack team. So you can join our Slack. When you register for an account, we always send you a Slack invite, and if you've somehow missed that in the past, we can still add you, submit us a ticket, and we also do have a ticket system for assistance as well. So a couple of ways we can help. TACC, the University of Texas, Texas Advanced Computing Center, where we support DesignSafe. I want you to kind of understand the scope and scale of what we have available for you. We are the largest academic supercomputing center in the US, funded by the National Science Foundation, and we have some of the largest academic supercomputers in the world, and that back all of our portal capabilities. And in addition, we have about 200 staff members, full-time staff members at TACC. None of us are professors. So our mission is research support for the entire computational research community of all scientific disciplines. And we support some specific projects like this natural hazards community of DesignSafe. And you do not need to have NSF funding to use these resources, as many of you who have used our resources already know. You get a login, you get an account, you can use our resources through the portal. So we're happy to support all of your research, and we're glad that for anyone who can access them that wants to access them, to use them. Let's see, Gidavon has asked a question. Do you see that, Sylvia?
Oh yeah. I don't know is my answer.
Okay.
Go
yeah,
in
I
and
didn't know.
test
I didn't
it.
know there was a fire module.
Yeah.
For...
I don't know if that module is part of whatever. If it's, I think it's a separate program. I don't think it's within the OpenSees itself. It's a separate OpenSees version with other modules. So it could be something that could be made available on DesignSafe as well. I think we should talk about that. That's a good point.
Yes, Sylvia, I agree.
Yeah.
And I will say that the National Science Foundation in the past year had, for many years prior, it was a very focused, narrow activity to be involved in wildfire, because many other U.S. government agencies deal with wildfire research. But a little over a year ago, the National Science Foundation let us know that our activity in wildfire research is more broadly available. And So this is great. Thank you. Sylvia, yes, let's definitely look into this, and you know, we want to welcome the wildfire community into DesignSafe as well, going forward. And I think we'll find some other larger wildfire projects that will be utilizing some of our resources in the coming year, and we will definitely be communicating and hopefully have some webinars on that as well.
Well, and what's cool about OpenSees Fire is not just a wildfire thing, is modeling the effect of fire on the structure. And I think after what just happened in downtown LA, that could be some, there's definitely going to be interest in it. One thing I also wanted to point out and highlight is about a month and a half ago, someone had reached out to Tim that he would like to, you know, submit a proposal to NSF for some research they're doing, and wanted to leverage being able to do the analyses on DesignSafe. And again, as Tim pointed out, there is no cost in doing the analyses on DesignSafe. But what was interesting was this person was early on and they wanted to integrate OpenSees into their workflow, but their whole workflow is in Python. And so they wanted to understand how that would work. And we're like, well, you know, you could do it in OpenSeesPy as well, or you can integrate it this way or that way. And so we had a meeting of just trying to figure out how to best help with his particular task and project. And that's what you're getting at DesignSafe, as Tim pointed out, a whole infrastructure of hardware, but as well as brain experiences. So many, I mean, Wanyang and I chat on Friday afternoons about the different things that you could do with OpenSees, because he has one set of experience and I have a different set of experience. And so there's always something to learn from this community. And so by bringing in what you're doing and communicating, don't work in a bubble. And this is what I find is a lot of people come in and I've got this huge structure that is not converging. I was like, well, start from small and get the team involved early on in your projects. And I think there's a lot to learn, which is why today I threw a lot at you, because I wanted to just so that you know that that stuff exists, right? Put it into your brain, it's there. And so then when it applies to you, your brain will figure it out on its own. So that I'm hoping that this is going to help you to think of beyond what you can do. And any more questions or comments? It's nice to see some familiar names and faces.
Reminder that we would love your feedback. I dropped that link back again in the most recent chat. You know, positive or negative, you know, I mean, we learn best and adapt and adjust to, you know, hey, some critical comments, or I'd like to see this or that, or more of this or that. So would love to hear it. In this particular webinar, I will say that we knew it would be extremely well attended, and also we needed to get a lot of information out. So we didn't include a hands-on part. We have been doing that a lot in the last couple of years to try and add hands-on participation with some specific examples. If that's of interest to you, for another OpenSees webinar, we'd love to hear from you on that topic of doing something hands-on, or if you feel like you learned enough and as you go through the user guides, you know, you'll be able to pick it up yourselves and that. But we'll continue. Sylvia will continue to work to enhance all of our capabilities and the user guides and our any learning and training materials. But your input, as you know, just asking the question about fire, right? This is gonna, thank you. You know, those are the kind of things that really help our entire research community. So thank you for that. All right, thanks everyone. We'll go ahead and close this out. I'll leave this open for a few minutes so that if you need that link for the survey, it'll be available. And this will be put up on YouTube in the coming days for future viewing. So thank you all so much.
Thank you.